I've always been fascinated by the invisible forces that shape our universe. But what if I told you that everything we see, touch, and experience is just half of the story? There's a whole other world out there, a mirror universe of sorts, made up of something called antimatter. And lurking in the background, pulling the strings of reality, are mysterious entities known as virtual particles. So, what exactly is antimatter? Well, imagine every particle you know, electrons, protons, neutrons. Now imagine each of these has an evil twin. Okay, maybe not evil, but definitely opposite. These twins have the same mass as their normal matter counterparts, but their electrical charges and other quantum properties are reversed. This is antimatter. But hey, don't go looking for antimatter planets or antimatter people. In our observable universe, antimatter is incredibly rare. Why? That's one of the biggest mysteries in physics, but we'll get to that later. For now, let's focus on how we discovered this elusive substance in the first place. The story of antimatter begins with a particle called the positron. In 1932, Carl Anderson discovered this positively charged counterpart to the electron. It was the first experimental evidence of antimatter, confirming theoretical predictions made by Paul Dirac a few years earlier. But positrons aren't just some abstract concept confined to physics labs. They're actually used in a medical imaging technique you might have heard of: PET scans. When these positrons encounter electrons in the body, they annihilate each other, producing gamma rays that the PET scanner detects. PET stands for positron emission tomography. In this procedure, patients are injected with a substance containing radioactive isotopes, often a form of fluorine. As these isotopes decay, they emit positrons. It's like turning your body into a tiny antimatter factory for a brief moment. Now let's shift gears and talk about something even stranger: virtual particles. In the quantum world, particles can pop into existence out of seemingly nothing, exist for an incredibly short time, and then disappear again. These are virtual particles. They're like the magicians of the quantum realm, appearing and disappearing in the blink of an eye. When two electrons repel each other, for instance, they're actually exchanging virtual photons. It's as if the fabric of space-time itself is alive with these ephemeral particles, constantly popping in and out of existence. When a particle meets its antiparticle, they don't just disappear. They unleash an enormous amount of energy, converting their entire mass into pure energy. This process follows Einstein's famous equation, E=mc2. It's not just theoretical, it's happening all around us, all the time. When matter and antimatter collide, they annihilate each other, releasing an enormous amount of energy in the process. In fact, antimatter annihilation is happening in your body right now. Potassium-40, a naturally occurring radioactive isotope, occasionally produces positrons that quickly find electrons to annihilate with. Positrons might be the most famous antimatter particles, but they're far from the only ones. For every type of particle we know of, there's an antimatter counterpart. When an antiproton pairs up with a positron, you get antihydrogen, the antimatter version of the simplest atom. Scientists have even created more complex anti-atoms. In 2011, researchers at CERN managed to create and trap atoms of antihelium-4. But creating and storing these anti-atoms is incredibly challenging. They need to be held in complex magnetic traps to prevent them from coming into contact with normal matter and annihilating. Let's talk about how nature itself produces antimatter through various decay processes. One of the most common is beta decay, where a neutron in an atomic nucleus transforms into a proton. In beta decay, a neutron transforms into a proton, emitting an electron and an antineutrino in the process. Yes, you heard that right. An antineutrino, the antimatter counterpart of the ghostly neutrino particle. Cosmic rays, high-energy particles from space, can create antimatter when they collide with particles in Earth's atmosphere. These collisions can produce pairs of particles and antiparticles, including positrons and even antiprotons. It's like nature is running its own particle accelerator experiments high above our heads. Particle accelerators are our primary tools for creating and studying antimatter on Earth. By smashing particles together at incredibly high energies, we can create conditions similar to those just after the Big Bang. These collisions create particle-antiparticle pairs, mimicking the conditions of the early universe where matter and antimatter were constantly being created and annihilated. But here's a mind-bending thought. antimatter is being created all around us, all the time. Sometimes in the presence of a strong enough electromagnetic field, virtual particle-antiparticle pairs can be separated before they annihilate, becoming real particles. This is called the Schwinger effect, and it's thought to occur near extremely powerful objects like pulsars and black holes, where the electromagnetic fields are strong enough to tear apart the very fabric of space itself. Let's return to virtual particles. You might think a vacuum is empty, but in quantum mechanics, it's anything but. The vacuum is actually a seething foam of virtual particles constantly popping in and out of existence. This quantum foam is the source of vacuum energy, and it might even explain dark energy, the mysterious force causing the universe's expansion to accelerate. According to our best theories, equal amounts of matter and antimatter should have been created in the Big Bang. So where did all the antimatter go? This question, known as the baryon asymmetry problem, is one of the biggest unsolved mysteries in physics. This asymmetry between matter and antimatter is crucial to our existence, yet we don't fully understand why it exists. Thanks for joining me on this journey into the invisible world of antimatter and virtual particles. We've only scratched the surface of these fascinating topics. Every time you look around, you're only seeing half the story. The other half, the world of antimatter and virtual particles, is there too, hidden but profoundly important. Until next time, keep questioning, keep exploring, and keep wondering about the mysteries that surround us.